Okay.
Okay, so far so good. What Abhinandan has asked now is that what is the difference between a database, a data warehouse, and a data lake? Okay, this
Mhm.
is, I think, to my knowledge, it is a very important theoretical question to be cleared by any data professional, right? So let's just get into that. This is database, right? I think I am sorry. This is going to be data warehouse, and this is going to be data lake. So ideally, if you look at things, the thing is that this can be categorized into few things. We can just say, first of all, Partho, you are aware of this. What is the difference?
Yes, yes. I
Okay.
more or less, but not exactly what maybe Ovinan looking for, but yeah, I have little bit of idea.
Okay, we'll come to that, but let's just for the sake of time, we will just go and give a very quick answer to this. Okay. So when we are talking about database, data warehouse, and data lake, first of all, understand that these are not entirely different, paradigms of data,
Mhm,
right?
mhm,
These
mhm,
are same paradigms of data. It is being used in such a way they are purpose optimized, right? So what are the purposes? We are going to come to it, right? We just talked in very great detail about OLAP and OLTP. We are very clear about that, right?
mhm,
In a typical database, the use case is day-to-day transaction processing. So this is transactional.
mhm.
Do you know the meaning of transactional?
Um, Transactional means it should have been either not for analytical purpose, but should be in like a columnar database. Row and columns should be there just for
No,
reading and
not columnar database. Not
um,
columnar database. We'll go into very detail of that, but let's not
okay,
go into columnar database. First of all,
okay,
this is we'll understand. This is OLTP,
okay,
right?
okay.
That means what? That means
Relational database.
relational normalized. We know this much.
Relational and normalized. Okay, right, right.
We know this much, right?
Hmm, hmm.
I'm just waiting to hear, Partho, anything that triggers on this word transactional. What is the property of transactional?
Yeah, I mean, as you mentioned, like, I mean, yeah, asset property is
This
definitely.
is this is ACID compliance. You need to
Mm,
understand this very carefully, right? So this has to be ACID compliance. So I'm
mm.
not going into the details of ACID. I think we
Hmm,
we also know as atomicity, consistency, isolation, and durability, right?
hmm.
So this kind of actually ACID compliance database is required for what? Application databases, which is going to have faster writes, slower reads, which are going to have
Faster
normalized
writes.
normalized
Hmm.
data, and which are what? Which are not having large history. Okay. This is
Oh,
limited historical data.
okay.
Are these 4 points clear on the database side of things? It is day-to-day transactional processing. It can be used for real-time business operation, current state of data management. It is a normalized data structure. Typically, this is row-oriented.
Hmm.
We will go into very great detail of row-oriented and column-oriented very soon. But these 4 or 5 things that I have written there, any questions on that? If not, I'm going to get to the data warehouse part of it.
Yeah, okay,
I'm
fine.
good.
Okay, very good. Partho, any question?
No, no.
Okay. Let's get some examples of this kind of database. What is some example? Can you guys tell me?
Yeah, the normal Oracle database, SQL
Very
Server
good.
database,
Very good. Very good.
Teradata
Oracle,
database.
Oracle SQL Server. Mm, let's go MySQL.
Mm.
And you can also
Teradata.
say Teradata to some extent, yes, but more than that, this is PostgreSQL.
Postgres.
PostgreSQL. PostgreSQL.
Hmm.
This is having it, right? Okay. I think we are clear on this side of things, right? Now
Hmm.
let's come to data warehouse, right? First point on data warehouse. Can you guys tell me
Yeah,
what
analytical.
has to be? Yes, very good. It is transactional. This is analytical, right? Now,
Right.
if this is analytical, what does it bring into architecture? This is OLAP. We
OLAP.
talked about a very great detail, which means this is DNOD. Understand
Hmm.
this so that you will never forget throughout your life. This is, I mean, step one and step zero of data engineering. See, we
Hmm.
have just talked about OLAP and OLTP and how this concept connect back very beautifully to the question that you just asked, Abhinandan, right?
Hmm.
So,
Hmm.
so, so just think of it, right? This is denom, right? Now,
Hmm.
this is which means what? We are using the data for what? For historical
Select.
analysis, right?
Historical
Historic
analysis. Hmm.
historical analysis, and what, which means what?
Select.
Which
Select factor.
select optimized, which means read optimized, read
Hmm.
Read
fast,
up.
right?
Yes.
Okay.
Yep.
Now there are few things, and we are going to get into, and just remind me today we want to do that. Whatever time I'll go, if you guys want to go 15 minutes more into it, this is very important to go into this understanding of why this is happening. We will go into that. This is mostly columnar store.
Okay. 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 Makes sense.
This was row store. This is column
Right.
store. Now, this is also, we are saying that there are different kind of denormalized schemas, like, star schema, snowflake schema. There are cleaned and transformed data. There is, well, I'm not going into all those details, but I mean, in terms of examples, can you guys give me some examples of say highly analyzed or cloud data
Yeah.
warehouses?
Cassandra.
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 Cassandra is columnar, yes, of course, Cassandra, yes. Okay, but Cassandra is used in two different places. I mean, we there is a use case for Netflix that Cassandra is used in storing the slider of the movie that you are watching. So if you pause the movie in say
Hmm.
53 minutes 8 seconds, that data
Hmm.
is also stored in Cassandra, and it's been so it is, what I'm trying to say is that it does not have to be always analytical, but
Always analytical.
yeah,
Okay.
but one thing that stands out, everything cloud data warehouse today is what? Snowflake, right?
Right.
We are going to come into what Snowflake is and why not, right? So we are going to come that. Then what we have? Google BigQuery, all right? Then we had Amazon Redshift, right? RDS,
Okay.
sorry, not RDS, Redshift, I think. These are all example of
And
what?
then Cosmos, Azure
Cosmos is
Cosmos.
there, Cosmos is there. And by the way, Partho, Teradata is an example of OLAP, right? Teradata is not
OLAP.
an, yes. Teradata does not, so which application have you seen that
Yeah,
it
yeah,
is
yeah. True, true, true. Yeah. Although it is a relational database.
relational database, but
Yeah.
it supports
But
ACID.
most of the
It
case,
is supporting
actually,
ACID.
we
It
use.
is support,
Yeah, yeah.
no. So it is not relational. So first of all, it is every database you can make it relational. So my point is that it is supporting ACID, but Teradata is typically an analytical use case purpose, wherein it is optimized for read, right? It is a read
True.
optimized database.
Mm.
So it is clear this much. Are we are
So,
we are we understanding this?
right. Yeah. Yeah. So I think this. I mean, there was another old tool, MS Access. MS Access was also like a relational database, right?
No, MS Access is, you can say that there is a relational database. That is because you can actually drag and drop files, and you
Drag
can
and
write,
drop.
and you can
Right.
write queries on top of it. But see, the term of relational database, it is on Microsoft stack. It only, I think, is SQL Server,
SQL
right?
Server and MySQL.
MySQL is not Microsoft, right?
Oh, sorry.
MySQL,
MySQL is not Microsoft. That's
yeah. Microsoft is, yeah, MySQL, I think I forgot the name of the company
I
who is
forgot.
doing
Yeah.
it. Yeah.
It
Anyways,
comes up when
but
you start it on. Right.
yeah, yeah, yeah. So by the way, when you look at databases, see,
Hmm.
building a database and how things are done is one level deeper than what we are understanding. This is
Right.
this is the difference. You have to understand that how are they used for, in what other use cases, whether they are transactional,
Exactly.
whether they're analytical, whether they're these things, right? Now, let's go into very quickly into the details of data lake, right? What is data lake? Why?
Another example, sorry, just where does Databricks sits?
No, no, Databricks is, we will come to that. Databricks is a distributed engine for optimized large data warehouse processing.
Okay.
They have a paradigm which is called lake house, which is
Right.
which is a mixture of data warehouse plus data lake, which is very advanced, which supports if you do not understand data lake, you will not understand data warehouse, which
Mm.
supports the denormalization plus the ACID property. And I think no, so denormalization, it also supports ACID. It was ACID compliance, and I think it was to some extent. Yes, it was infinitely scalable. It had all those things. Anyways, I think
Okay.
let's not deviate.
Yeah,
Let's not
right, right.
deviate.
Yeah.
We'll
Hmm.
go to Databricks is the name of the company. Databricks is not the
Right.
name of the name, not the name of the
Not a
technology.
database. Right.
What we are discussing here, database, data warehouse, and data lake, these are all technical paradigms, right? These are not the name of the company, right?
Right. Right.
So the name of the company is different, right? Anyways, we'll go there later when the time comes. Let's just
Okay.
make on progress here. What is data lake, right? First of all, data lake's use case is big data storage.
Hmm.
Very clear, you have to understand this thing, right? Second thing is it is used for advanced analytics, which means, can you tell me what advanced analytics leads to?
Data science usage.
Yes, exactly. ML AI or ML data science AI use cases, right? What happens in data lake? It is basically, it's a raw data store.
Hmm.
This is a raw data store. Okay.
Okay.
It can have multiple format of data. It can be stored in file of CSV, Excel, and it can be Parquet, it can be anything. It is multiple format. Here in data warehouse, your data was where? Into a table. It in data lake, it can be in multiple format. It can be your audio file, it can be your visual file, it can be your picture, it can be anything, right? And
Hmm.
it is it is it is having high scalability, which means that it can store TBs and PBs of data, and
Hmm.
it supports unstructured data, which is like video file and etc., whatever we talked about, right? And other thing is what? It is of unlimited, yeah, we talked about high scalability, multiple data. Yeah, it is a low storage cost. Low
Okay.
storage cost. What is an example of this? First example is Amazon S3. Second example is what? Google Cloud Storage.
Mm.
Third example is what? Azure Data Lake.
Azure. Yep.
Okay. In fact,
Okay.
uh, Hadoop HDFS is also sometimes used as data lakes, right? Okay.
Yep.
Now, I will just take a brief pause here. This is extremely important concept to understand the difference between these three. Any questions here? Let's clarify.
Actually, I have not worked on data lake so far. So I'm okay with this database and data warehouse. But data lake
So,
one,
so the
yeah,
data lake is a storage layer, Partho. The thing is, once you are into the data lake, right? The data that you are loading into data warehouse, that comes from somewhere, right? It might be
yes.
extracted from a OLTP system, but then you might have to just store that data, not necessarily into a database, right? You can just store that data into a cloud storage bucket, and you can have that data exposed as a part of your S3 or everything. And in recent 2024, I think December reInvent, that is the AWS summit for reInvent, they have declared S3 is now iceberg compliant, or iceberg is compliant with S3. What does that mean? Iceberg is a technology which means that you do not have the file in database, or do not have the database data loaded within the database. You are not writing insert into table to load that data from a file to a database table. You have the data in 10 different files, and that 10 files are placed into S3 bucket. You can open up Iceberg and you can directly write a select query, and it will hit that 10 files and retrieve you the result.
So you mean Iceberg and S3 are compatible now?
Yeah, now that's the biggest announcement that is they have made, AWS.
Now S3, actually, I have a little idea on S3 because when I was doing the Amazon AWS basic trainings and course, that time I was doing some hands-on on S3. Although the conceptual wise, yeah, not much clear. Yeah,
Is
now
simple
I
things,
understand.
right? Do you understand now, or do you have any
Yeah,
questions
yeah.
now? So
No, no, I
it can
understand.
hold multiple format of data. It is,
Yeah.
and now it is queryable, right? It is highly scalable, low storage cost. Those are the things, and it is used for
Hmm.
advanced analytics. If you remember
Yeah, I
this, you
understood
know.
now. So basically, all data lakes examples are mainly clouds. I mean,
Data lakes are
cloud database.
built on cloud, but HDFS is also a data lake you can consider, which I did not write here. I can write here HDFS, which
Oh,
can be
HDFS.
in local cloud systems. This
Okay,
is Hadoop
on-prem.
HDFS, on-prem also.
Okay,
So
okay.
it is a concept, right? Let's not confuse between concept and the provider, right? It can be
Okay.
cloud, it cannot be cloud, right?
Yeah.
Okay. I think we are almost. We'll continue if you want. We'll continue for another 10 minutes. So I just want to touch
Yes,
one
yes.
topic, and then we want to drop. Is that fine with you, Abhinandan?
Yeah, absolutely.
Okay. I actually had to join another meeting, but I
Yeah.
requested Maharaj that I will be joining in another 10 minutes. This is very
Yeah.
important, and
Yeah,
thank you so much, Abhinandan, for asking this question. Let's get
absolutely.
into the very detail of these two guys.
Actually, that was my second question. What is the difference? Like, can you explain a little bit about the row-oriented versus
Yes,
column?
row-oriented and column-oriented data store.
Okay, thank you.
Unless, okay, and after we do that, we are going to conclude the session for today, and we can take it later, right?
Mhm, mhm,
So there can be two ways to organize any kind of databases, be it relational, non-relational, or like whatever, right?
mhm,
One is row-oriented, one is column-oriented.
mhm,
Let's look at the difference, right?
mhm.
If I ask you, how is data stored within the database? Can you tell me?
As a record, as
Yes.
an
What does that mean?
record means as an entry which can be stored. I mean, thinking it to answer this perspective, it would be like a record which will be stored in a
Okay.
row wise.
Okay. Yes, you are right. One is, let's take an example.
Right.
There is a table, name, age, and city. Okay.
Mhm,
So
mhm,
you have person A who lives in LA, and say we have 20, right?
mhm, mhm,
Person B
mhm,
who lives in, say, SF, and his age is 13. And then there is person C who, say, lives in, I don't know, maybe San Diego, and
mhm,
whose age is 40, right? Now, if this is a row-oriented database,
mhm.
you know how it will be stored in disk. Data has to be stored in the disk, right? You are writing that table into the memory of the computer, because the table is not, I mean, forget about cloud or on-prem. You are actually putting that data of all this table data goes into computer memory, right? It goes into a memory, right?
Yep.
In the memory, or say we can also say in disk, right? How is
Right.
going to be
Right.
stored in the disk? Let's understand that. So the storage for row oriented is this. Partho, are you listening? This is very
Yes,
important.
yes. Yeah.
So let me first draw, then I'm going to explain. And this is very simple to understand, but very critical for a lot of, you know, interviews and other things that might come up, right? So this conceptually, if you are clear, right, nobody can beat you. Okay. So I was not having enough space here, but what I wanted to mean here is that each row will be stored one after the another in row-oriented database, which means what? The last candidate, right,
Hmm.
of or the last column of
Hmm.
the previous row and the first column of the next row, the last column of the previous row and the first column of the next row will sit
Adjacent.
Next to each
adjacent
other.
next to each other.
Right. Hmm.
Clear?
Hmm.
Yes.
Hmm. Hmm.
Okay. Now, this architecture is a very fundamental architecture that allows for write optimization. Why? Because
Hmm.
you have to add a new record, say D. You do not have to go anywhere. You know the exact place you need to write it. This was for A, this was for B, this was for C. I know that my write will happening on this particular block, which is D. So in D, it will just start from here. Are you getting it? We just
I mean,
append to the end of the current data. What I'm trying to say is that you do not have to think that whether the row D, how it will be stored into the memory, because it goes on simply append to the current data, right?
I mean,
So it will just append.
even if it appears lately.
Even if so that does not matter. Today we have three rows, right, Partho? We have row 1A, row 2B, row 2C, right? Now I'm saying that there is a row D that is getting added, say late or now, whatever, right? Where will this D sit? D knows exactly where to sit. It will always go and append to the next one, which is this place. Correct? It
Mm-hmm.
does not have to think that where I'm going to sit. It will always append to the last, append to the last, append to the last. Correct?
Mm-hmm.
That is why this is write optimized and it is used for OLTP. Any questions till now? Why it is write optimized?
Because the last element of the previous row is adjacent to the first element of the next
Because
row, which
of
makes it
course it
easier
is,
to read.
yeah, it no
Right.
right optimized. So
Sorry.
it is just sitting one adjacent to another. Every
Hmm.
row that you put, it will just go and sit one adjacent to another. So the next row you put, it will just go and sit to another. It's as simple as that. In the memory.
Hmm.
Artho, do you
Yes,
have any
yes.
question?
No, no, it's okay. I understood.
Okay. Now, if you look at the reading part of this particular paradigm, right? How do you read from a row row store database? Now, that's where the problem comes in, right? Because remember, our
Hmm.
data was in that structure of this. So you had
Hmm.
A here, you had B here, you had C here, you had D here, right?
Hmm.
Now, let's assume that the disk can only hold the the bytes of data that is required for the storage, right? So what would happen is that in case of a read, you might want to read the full select star, or you might want to read some selected column, correct?
Mm.
Your pointer or logic have to jump from one memory space to another to retrieve the value.
Yes.
That is where your time would require in order to read the data from the row optimized storage.
Oh, okay.
Suppose if I am saying, get me the sum of all these 30 plus 20 plus 40, 90, get me that. You are writing a query. Select star from this table, sum of this. Where will that sum come? First of all, it will take this one, then it will hop on this, no, then it will hop on this, no, then this will hop on this. Yes, there is a value. Then it will hop on this, no, then it will hop on this, no, then this, okay, there is a value. So in case of that logic, it has to traverse from one to say few, I mean, gaps in between, and then come up another, then take another value, right? And then it is going to sum and then it is going to return, right? So in this case, if it is adjacent, right, it is not going to solve our purpose for fast retrieval. So reads become slower. Is that is it okay? Where was I able to explain why it is read is slow?
Yeah, I mean, I'm good so far. I have some
Hmm.
questions, but I think
Okay,
after you
we'll take it
explain the
there.
column one, probably it might
Yeah.
be.
Yeah, Partho, are you okay?
Yes, yes. Okay, okay.
Okay, now understand the column one. Same table. Let's just draw it in a bigger way. Okay, this is name, this is city, and this is age. Okay, this is A, this is LA, this is 20, this is B, this is San Francisco, this is 30, this is C, this is San Diego, and this is 40. Simple table. Okay,
Hmm.
we are talking columnar database. How will this store? In columnar database, the storage will be by column, which means that similar in memory. So this is memory, right? This is memory. Sorry, you can call it, I keep on calling memory and disk. Actually, this is disk. Memory is the RAM. Don't think it as memory. Just think it as disk. Okay. So in
Hmm.
disk, how will it look? It will look like this. A, B, C, then LA, SF, SD, then 20, 30, 40. Why columnar? Your database is optimized to reach each column, and it will put the column values adjacent to each other.
Mhm.
Now, if I tell you, give me the sum of the whole age, 20 plus 30 plus 40 are sitting adjacent to each other. My retrieval is faster. So this is read optimized, because it does not have to jump these ones and jump these boxes as previously it was doing. My retrieval directly comes from adjacent values, which means that this is the ideal use case for analytical queries, which means
Collapse.
OLAPs, which means if you have denorm, we should always go for columnar databases. Partho,
But
any question?
most of the warehouse projects still have relational database.
Yeah. That is fine. So I can give you a 7 o'clock blade, you can shave and you can cut the lawn grass. Both will do.
Hmm.
But what is that 7 o'clock blade is used for? Ideally, is this. You can definitely do whatever, but architecture wise, if you put columnar database, that's where you are getting the performance. And why you are getting the performance benefit is this reason. Most of it has it, and if you go to companies like Google, Netflix, Facebook, they don't use anything else than columnar databases for analytical purposes. Does your select query change? Your select query will not change. What will change? The way that you are retrieving the value. Why it will change? Because the way that it is stored within the database, that is fundamentally different.
Hmm.
The one way the retrieval is faster, one way the retrieval is slower. I will stop here. Let me stop the screen recording and let's